Good evening, students. Welcome to Chemical Crystal Palace. Today's topic of discussion will be classification of alkyl halides. So, how do we define a alkyl halide or haloalkane? Any halogen derivative of alkane is called haloalkane or alkyl halide. Taking an example of an alkane, let it be ethane, C2H6. This is ethane. When any of the hydrogens of ethane is substituted by halogen group which we denote by X, let it be fluorine, chlorine, bromine, iodine, then it's converted to C2H5X. This forms the haloalkane or alkyl halide. Basically, haloalkanes are formed by the replacement of the hydrogen atoms of the alkane by the halogen atoms. So today we will classify the haloalkanes on the basis of the number of halogen atoms present in the molecule. They can be monohaloalkane, dihaloalkane, trihaloalkane, and also polyhaloalkane. So if we consider this molecule CH, H, H and X, here we will find that only one halogen is attached to this carbon. Only one halogen group is attached to this carbon. So this haloalkane will be named as monohaloalkane. We know the meaning of mono is one. So as one halide is attached to this alkyl group, so it is called monohaloalkane. Taking an example of a second molecule, we have CH, H, X, X. Here we see that two halogen groups are present. So, such a molecule is called dihaloalkane. We know di means two, so such a molecule is called dihaloalkane. Now, taking example of the third molecule, we have C, H, X, X, X. There are three halogen groups present in this molecule, so it is called tri-haloalkane. Tri means three. When more than three halogen atoms will be present in any alkane, it will be called polyhaloalkane. The next step of classification of alkyl halides is on the basis of the nature of carbon atom. So, according to this classification, we classify the alkyl halides into primary, secondary, and tertiary. Or we denote primary as 1 degree, secondary as 2 degree, and tertiary as 3 degree. Alkyl halides. Now we take examples of some alkyl halides. Firstly, methyl chloride, and the next is always remember that the valency of carbon is 4. Now, if we expand the structure of methyl chloride, it comes out to be CHHHCl. Now, we see that the halogen group is connected to this carbon atom. Correspondingly, this carbon atom is connected to how many other carbon atoms? Is this a carbon atom? Is this a carbon atom? Or is this a carbon atom? All the three are hydrogen atoms. So there are no carbon atoms present other than this. So this type of alkyl halide in which the the halide will be connected to that carbon atom which is connected to no other carbon atoms or only one carbon atom. Such halides are called 1-degree or primary alkyl halides. The next example which we take of a primary alkyl halide is this. We expand the structure as now this chlorine or the alkyl halide is attached to this carbon atom. Further, this carbon atom is connected to one hydrogen, and one carbon atom. We do not see these hydrogens. We see this carbon atom only, to which directly this carbon atom is attached, which is connected to the alkyl halide. Now, such a type of alkyl halide in which, as I already mentioned before, the carbon atom connected to the alkyl halide is further attached to no other carbon atoms or only one carbon atom, such alkyl halides are called primary alkyl halides. We take an example of a next alkyl halide in which CH3, a methyl group, and a halide. Now taking an example of this chloride is attached to this carbon, and this carbon is further attached to one hydrogen and two other carbon atoms. So such type of a halide will be called a 2-degree or secondary alkyl halide. And this carbon is called the 2-degree carbon. The third example we take of taking example of bromine. Here this halogen is the bromine atom here. This bromine is connected to this carbon atom, and this carbon atom is further connected to 3 other carbon atoms and no hydrogen or any other carbon atom. So such an alkyl halide will be called a 3-degree or tertiary alkyl halide. And this type of a carbon atom is called a 3-degree carbon atom. Here it was 2-degree carbon atom, here it's 3-degree carbon atom, and here it is primary or 1-degree carbon atom. Here too it's 1-degree carbon atom. So now taking the general formula of alkyl halides, it is, we know the formula of alkyl halides is Rx, in which R is any alkyl group. Taking example of, it can be methyl, ethyl, propyl, etc. And the halogen, that is the X group, can be fluorine, chlorine, bromine, and iodine. The general formula of alkyl group is CnH2n plus 1, and general formula of alkanes is CnH2n plus 2. Make sure that in alkyl group, one of the hydrogen is missing. That is, if we take example of methane, this is an alkane, but in case of the methyl group, this is the alkyl group in which one of the hydrogen is less. Hence, the general formula of alkyl halides is CnH2n plus 1 with the X group, in which X is the halogen. This is not the bond, this is not bond. This is for notation.